So you know what Kubernetes is, but you're not entirely sure how it works. This is the video for you. We're going to cover what goes into a Kubernetes cluster so that you can have a better understanding of how your entire cluster is running by figuring out what each of the nodes does and where you need to prioritize your resources when using Kubernetes. When we're talking about Kubernetes, we're always going to be talking about a cluster. And that's because while you could potentially run everything that you need on a single machine and just kind of run it on different ports or whatever, in reality, that's never how a Kubernetes cluster is going to be run. So we're going to look at entire clusters here. And within the cluster, we're going to have different types of nodes. The first one is going to be the master node. And you can have multiple master nodes. So it's good to keep that in mind. You don't just have one master. You're going to probably actually have more than one so that you have high availability. In the case of one master node actually has some issues with it, the other one can pick up the slack. But the master node is the brains of the operation. It's really what does all of Kubernetes' magic. It's responsible for implementing Kubernetes' logic to everything that we do. In addition to these nodes, we have worker nodes, often just referred to as nodes. These are going to be the other machines in your cluster that are in charge of running the actual workloads that you have. So it's going to go off and run the pods that you described so that you can actually achieve things using your Kubernetes cluster. This is where things get deployed. So if we look into the master node, this is commonly referred to as the control plane also. So if you take all of the master nodes, that's your control plane. And like I said, it's really the brains of the operation here. On the master nodes, we're going to run quite a few different processes that all do a little piece of the puzzle here to achieve the overall wonderful things that Kubernetes is able to do. The first one is going to be the API server. This is the entry point into your server. So anytime you want to talk to your Kubernetes cluster, you're going to go through the API server. And this actually happens also that anytime a node in the cluster needs to talk to Kubernetes, it's going to also go through the API cluster. So it uses its own API to communicate with itself. And that's why you can have things like a command line client like kubectl work, but you can also have an HTTP client that would allow you to do things. It's because it all goes through the same API server. So when we say kubectl get nodes, it's going to hit the API server, and this API server is going to perform some authorization and authentication to make sure that we have rights at all to even talk to the servers, and to make sure that we have the proper rights to do the thing that we're trying to do. And then once it knows that, it's going to dispatch that to other parts of the stack to actually achieve that. Moving on, we have the controller manager, and the controller manager is sort of the big overarching manager that manages a bunch of little processes that all kind of do their own thing. That's very small, but we can talk about them all as the controller manager segment here. And the gist of what they need to do is go from whatever we say is the desired state and make sure the actual state is that. So Kubernetes is all about state because we declaratively say, this is what we need in our Kubernetes cluster, whether that be nodes or pods or services, deployments, all of those things are held as state, and it's going to compare those with what is reality. So to take an example here, we're going to have our controller manager. It's going to see that the desired state is to have 5 running pods. And then the actual state is that there are 3 running pods. Say 2 of those pods actually ran into an exception and they crashed. So we're down to 3, but we need to have 5. So it's going to say, okay, this isn't quite right. I'm going to go ahead and make a plan on how we can fix this. And it's going to decipher what it would need to do to achieve the desired state in the minimum number of steps, essentially. So it's going to say that, okay, I need to start new pods. I need to have this happen. It's not my job to actually start them, but it's my job to figure out what needs to be done and to tell somebody else to go do that. So it comes up with the plan, and then it goes off and tells something to execute that until it gets back to the desired state. And then it's just going to wait. And it's worth noting that the desired state and the actual state can change based on things that we do actively or through passive means like a pod crashing, like I just said. If we had instead done a Kubernetes apply command to actually change the state of our cluster, then the actual state wouldn't have changed, but the desired state would have changed. So there would be a mismatch. The controller manager would come up with a new plan and it would execute that. One of the pieces that actually goes off and does the executing is going to be the scheduler. So the scheduler is in charge of figuring out where pods should run. And that's kind of a big deal because one of the things that Kubernetes gives us is the means to efficiently utilize, based on the rules that we have set by providing a scheduler, the infrastructure that we have. So we want to get the most bang for our buck when we're working with servers that we're deploying to the cloud. So the scheduler is going to try to optimize that by packing things into the server so that we're utilizing every last bit of the resource that we have without having waste or without trying to overtax a system. So an example of the scheduler in action is we, the client, use a Kubernetes command to say, hey, we need to scale from 3 to 5 pods. We're going to go through the API server. It's going to verify that we can do these things, and then it's going to hit the controller manager. Controller manager is going to come up with a plan. The plan is start 2 new pods to get us to the new desired state. And then it's going to reach out to the scheduler, which is going to assign new pods to the nodes. Notice that I say assign. It's just going to figure out which node is best suited to run this thing. And then it's going to communicate to that node to tell it that it needs to go start something. So it's worth noting that the scheduler doesn't actually start the pods, if that makes sense. Moving on, we have etcd, which is kind of the brain of this whole thing. Like, controller manager is the thing that's achieving everything, but we need to know where all the state is, and that's where etcd comes into play. So all of the state of our cluster is going to be stored in etcd as a key value store, right? And then we're going to make modifications through that by talking to the controller manager, because some things don't require us to go and take action. They just require us to change the state. So for instance, if we go ahead and we just add a new user that really just exists inside of state. So controller manager is going to just make sure that etcd gets modified. But it's important that we have this here and that it runs on all of the masters, because all of the masters are going to have a copy of this information, because etcd is a distributed key value store. That provides us with some safety, knowing that there's at least another backup if we have more than one node of our state. Because if we just completely lost the state of our cluster, that would put us in a pretty bad spot. etcd is really important because it's where our desired state is held. It's where all of the information that we're putting out there is going to be stored. This has nothing to do with application information, right? So if you have a database for a pod that you're running, that has nothing to do with etcd. This is all about, we say that we need so many deployments or so many pods or this user. All of that stuff is going to be stored into etcd, and it's going to be what the controller manager is comparing things against as it continues to run. These are the primary 4 things that are going to run on a master or control plane node, but they're not the only ones. We also have the kubelet, which is going to be the thing that actually runs pods. I said that the scheduler goes and tells a node that it should run a pod. The kubelet is going to be the thing that actually goes and does that. It also updates information with the cluster to say the state of the node that it's on. So this is going to let us report back to the master to say the health of the master, even though we're running on the master. That's its job, really. So it updates the node status, and it starts and stops containers as directed by the scheduler. In addition to this, we have the kube-proxy, and this is going to be the thing that does the work when we're trying to expose services. So we want to actually have something that's running on a node be accessible to the outside world, and it's going to route network traffic in between our system so that it goes to the proper node. And finally, what we need is a container runtime. And normally, I'm just going to put up a logo of Docker here. You'll notice that I say container runtime, but that doesn't always mean Docker. You don't have to use Docker. In fact, there are different container runtimes that you can use with Kubernetes, but Docker is definitely the most common one. So these are all the things that we need installed on our master and control plane nodes. We need the kubelet, kube-proxy, etcd, unless we run a separate etcd cluster, which we could then configure. It's going to have a scheduler, controller manager, and an API server running on it. So there's quite a lot that runs on a master. But what happens on a worker node? Well, this is it. This is what a worker node consists of. It's a kubelet, a kube-proxy, and the container runtime. And the reason for this is that master nodes and worker nodes are fundamentally the same in how they go about running containers, and the processes that run on a Kubernetes master server are going to be run through containers for the most part. So it's its own node that it manages. The difference there is that a master node isn't going to be flagged to allow normal pods to be deployed to it. It's not in the same pool of workers. So that's the only real difference between a master and a worker node when it comes to these things. Worker nodes don't have the extra things that we were talking about, so they don't have an API server and etcd and all of that installed on it. They're really just these 3 things installed, and then we just run pods from there. So when we're just looking at how Kubernetes works, this is really a description of what it is that it's doing when you're running a Kubernetes cluster. And I hope that you feel a little bit more confident knowing what goes into what Kubernetes is doing. Obviously, there's a lot that goes on with what Kubernetes is doing, but most of those details are really minute that you don't really need to know. It's more on a practitioner level of the things that you do with Kubernetes that are going to be the things that you want to learn. But it's good to have a foundational knowledge of what exactly the system that you're working with, especially when it's something that's going to be the backbone of your infrastructure potentially, what it's doing, how it's doing it. And that'll let you make more informed decisions when you're going to think about how you should change the hardware that you're running your infrastructure on or anything like that. So I hope this was useful, and I hope you have a nice week.